Hey, my name's Justin, and this is The Art of Repair. Today we're going to continue on episode 19, and what are we going to call this one? Episode 19.something.x, whatever, I don't know. There's definitely going to be multiple parts to this episode. I think it's very important to see everything that was done on that one with other devices that have that same issue. So I'd really like to make, not only an S6 Edge edition, an S6 edition, a Note 5 edition, S7 edition, S7, you know what I'm talking about. I think it's important, just like you think it's important, to be able to see the exact device that you're working on. So today on The Art of Repair, we're going to be doing an InFrame OnFlex soldering job for the Galaxy S6. Now, we know that the main problem with this is that the capacitive buttons wrap around the front, which makes it very difficult to take out the charging port. Not a problem anymore, because we got a solution. We got a workaround, and if you've seen the first video, you know what's coming. The popsicle stick. So, how does the popsicle stick method work? It works, and I'm going to show you here, by lifting up the bottom of this. You can see here on the sides that we have our capacitive button wraparounds, and if we take something here and carefully lift up, there we go. See, we're just lifting up just enough to get something under there. Don't forget to take out any kind of extra screws, anything like that. Make sure you pay attention to all the surrounding components. There we go. All right. On the Galaxy S6, something to really note here. And I'm going to show you. We're going to switch over to the microscope before we get started here. All right. So you see the charging ports right here. But do you see what I see? I see a microphone. That's something we need to be careful of. Okay. On top of that, there also is a button assembly directly under the charging port. It is pretty much exactly where my popsicle is. That's something else you need to be careful of. Be aware that we are working with a lower thermal mass component right now, so it's going to heat up a lot easier, and we do have to tackle that underfill. So we're just going to go ahead and dive right in because I've already done this one before, and we are just doing this to make sure that everybody gets to see the device that they're working with. So first things first, let's take care of this underfill real quick. I'm just going to heat it up. We're probably going to be right around 160 degrees centigrade, and I'm going to use my dental pick here, and we're going to jump on in and clean this up. All right. And I always like to weigh the device down just a little bit so I can work and build. I'm going to be honest, I really don't like my Hako. I really wish I had my Quick 861 right now. Alright. I feel like I don't use this thing anymore, so I feel like I don't know how to use it right. Alright, so you see I'm just making these little punctures in the underfill. We're starting to break it apart. Once I know what's going in there, we start breaking along the back wall. You want to be real careful with this. You don't want to scratch the small little daughter board there. This is not a race. Take your time. Alright, so we got most of that out. We're going to go ahead and change our temperature. We're probably going to go, I don't know, 330, 340, something like that. We're going to bring up the airflow. Right now we're at 2/10 airflow. We're probably going to go to half airflow. Right. So, where are my tweezers? There we go. Alright, so be aware, this is very, very important, that this charging port, even though I just cleaned out the underfill over here, that does not mean all the underfill is gone, okay? It just means that some of it is sitting under it, okay? So we're actually going to come and we're going to attack it from the side here. These little wings are going to allow us to lift it up. And we're going to preheat the area a little bit, and then we're going to come in and concentrate heat directly on the charge port until we start seeing wetting across the pins itself, or themselves, whatever you want, whatever. All right. Get back up to temperature, preheat a little bit, no biggie. And you can use that warming up to actually warm up the area around it. It's not at temperature yet, you see. All right. See, we're going to bring this down. Nah, no, we're not. We got this. All right, so we're going to carefully heat up the component, heat up the area, concentrate on our points. We see them starting to wet. Let's make sure our anchor points are wet. Remember, less thermal mass. There we go. This should release on its own without any trouble. Alright, we had to stop recording there for just a moment. I was having a little bit of a lag issue, but I think we are ready to rock now. Let's go ahead and continue with this repair. So we've got the charging port off. Next thing is to clean up the area. Let's move it up just a little bit. Alright, what do we got here? Because I am the most unprepared person ever. Flux out. So what we're going to do now is we're going to change the alloy that is currently there, which is lead-free ROHS, which has a higher melting point, to a lower melt alloy, which is going to be 6337. This also has a lower eutectic state. That means that there's a point where this solder is actually both a liquid and a solid at the same time. 6337 has a very low eutectic range. It's almost non-existent, so it's either one or the other. It's really helpful to know at what position you're in. Alright, so we have got our solder. Are we not even plugged in here? What's going on here? Oh. Technical difficulties. My soldering station is not turning on. Alright, problem solved. Alright, we'll give it just a second here, and as soon as we're up to temp, we'll go in there and take care of this bad boy. And here we go. Alright. Y'all can see it a little bit better. Alright. Now, remember, like I said, over here, we've got ourselves a microphone, so we need to be careful with that. The deal is, I'm just changing the alloy here. And I'm always forgetting to turn my air on. Now you see that, guys? Look at that. This has such low thermal mass that I'm going to touch this and it's going to transfer immediately. See that? So heat does travel very quickly on these small PCBs. Alright. Alright, so we're switched over to new alloy now. Let us grab ourselves a charging port. And let's put this back on. And grab it down at the bottom here. And we are going to put the OnFlex on. Alright, like I said, watch for your microphone. Make sure you're paying attention. That stuff doesn't start leaking over. You could totally cover it with Kapton tape if you are not as careful or you know yourself better than that. And I'm actually just going to reflow this one on, and then we're going to go from there. I'm down at 3/10 airflow with the same temperature as before. We're heating up right now. Alright, so let's go ahead and get this thing done. Alright, so now let's take our soldering iron and hit these pins real quick. And you guys can still see, we got to be careful over here near this microphone. We don't want anything to happen there. There's my stuff. Better angle. Alright, so now we're going to go in here and we're going to make sure our pins are good. There we go. All right. Man, I have been just having technical after technical difficulty today, but we're doing this. We're doing this. In fact, I think we're actually done. That was too easy. So let's go ahead and take this off. Let's get our popsicle stick out. Check our button. We also want to make sure that our port is flat, which it is. There we go, right back on our pins. Man, this was almost damn near perfect job. Next thing we need to do is we need to test it, but let's clean it up a little bit first. One thing you can do to protect your microphone while you're cleaning it is you can take some Kapton tape and you can cover up that little hole right there. See that? Now all I'm going to do is I'm just going to hold my finger down on it, and then I'm going to brush the top off here. That way we don't let anything inside that little hole, because it's no bueno. No bueno at all. Alright, we didn't use that much flux here. We were very easy on it, so there's really not much going on here. Alright. InFrame OnFlex charging. Does it work? Did he fail? Let's plug in and find out. Alright, we know together. Yes or no? Ooh, look at that. Power and another live demo unit because I got a whole bunch of them. Anyway, hope you learned something. This was InFrame OnFlex charging for the Galaxy S6. This can be used pretty much across all the new Galaxies that have the capacitive buttons wrapped around the front, unlike the Galaxy S6 Edge that does not have the buttons wrapped around the front. But with that being said, I did do a write-up on the mobile repair subreddit that actually details out all 3 different types of solder port jobs. Full component replacement, InFrame OnFlex, out of frame OnFlex. Go check it out.